It's really my privilege to introduce everyone here to Dee Yang, who's an assistant professor at the School of Interactive Computing at Georgia Tech. She got her PhD at LTI at CMU, and her research is broadly at the intersection of computational social science and NLP. Specifically, her group really focuses on the goal of modeling human communication and social context. And she wanted me to mention that in furtherance of this goal, she's been learning how to make cocktails, which is kind of a key component of mastering social context. And so her cross-disciplinary work has been published at leading conferences for both NLP and HCI, with numerous award nominations at EMNLP, ICWSM, SIGCHI, and CSCW. And actually, just a few weeks ago, she was revealed as one of next year's Forbes 30 Under 30 in science. And so, round of applause for that, obviously. And we're lucky enough to have her here to talk about some of the great research that produces these accolades. So welcome, Dee, and take it away.
Thank you so much for the very nice introduction. Okay, let's get started. Hello, everyone. I'm Dee. Today, I'm going to share my work on language understanding in social contexts. So before we get started, I want to introduce my fantastic lab. So it's called Social and Language Technologies. So the symbol you are seeing on the left is the logo designed by my students. Actually, you cannot see this type of ring very well. It's actually formed by words. And yes, so we are a thought lab and we submitted to NACO. And on the right, you can see all my grade students. So many of the work that I'm going to introduce today should be credited to them. So, okay, finally started. So we live in an information age. As a result, a language interaction between individuals is growing exponentially in all sorts of venues, informal, formal, even a semi-formal. For example, we have a lot of tweets every second being generated. And not only the interaction between human and human, the interaction between human and the robots is also increasing. Given this larger amount of data coming from social interaction, we must make sure that our technology can better support and serve human communication in social contexts in a reasonable way. And it does in terms of performance. NLP has had increasing success recently and produced industry applications such as search or personal assistant. Despite being sufficient to enable those applications, current NLP systems often ignore the social part of language. However, many of us believe that natural language contains both content and the social interpersonal information. Getting the content correct is not enough. There has been a lot of work in our community that focus on the content part and relatively less, but emerging, including many of the great work from AI too, about understanding the social part of language. It's really hard to kind of separate those two. For this purpose, from a theory perspective, we turn to some theoretical framework to help us better understand the relations between language and its functions in social settings. So here we turn to this systemic functional linguistics proposed by Michael Holliday. So this framework provides a social perspective to language study, and it views language as a social resource that the people use to accomplish their goal. And there are many meta functions under this framework. So the interpersonal semantics, which is mainly about the speech function, interpersonal relations. It involves the understanding of social meaning of language, emotion, opinion, arguments, politeness. The second dimension here on the top is called the ideational semantics. It reflects the context of social process in which the language is used. As a result, we pay more attention to how we use language in the real world and understand how language use reveal our social role, influence, power dynamics. And then the textual kind of include all the grammatical systems that is responsible for producing and managing the flow of the discourse. So those systems together create coherent texts that cohesive themselves and also in a given social situation. So building upon that, recently with my collaborator Dirk Hovey, we also proposed a set of social factors that could enable NLP systems to be aware of, or in order to easily model different social aspects of language. So this provides a more practical conceptual taxonomy for us, and it includes multiple dimensions here. So first, on the very bottom, we have speaker, like it will involve a lot of speaker characteristics, such as some of the consistent demographic attributes like age, or some of the changing varying interests like hobbies or preference. We also have the receiver, who is the audience here. So means that from whom this message is sent to whom. And it could be one person in a dialogue, or multiple people in a conversation, or millions of people in a broadcast way, even like with unknown audience. On top of that, we have the social relations. So here, the social relation refers to the relation between the speaker and the audience. So we may have like family, friendship, seniority, competitor, a lot of interesting social relations here. And then on the top, we have context. We view context as a container or holder while language interaction happens. So it could be the domain, language, or topic. So context is also related to the Greece maximum of the quantity and the relevance. We also have social norms, so refers to some of the accessible group conduct, common understanding, or informal rules. So it representing speaker and the receiver's basic knowledge of what others do and think they should or should not do. So so like one recent work from AI to also like highly reflect this type of social norms in our language interaction. Language and culture are intertwined. So language reflects the society, culture, identity, and the customs, as well as some of the values. So one of the example we had is that in Japanese, the expression of hierarchy pose like very high level of politeness and the formality than in Western cultures. And also the term of address also vary in terms of social and age difference. For example, the young members or less junior members will address their boss, or senior members with a term of relationship compared to using like personal names. All of this together serve the communicative goal. Like the goal here could be, what's the purpose of this message? Is it to enhance like relationship bonding? Is it for request? Is it for persuasion? Or is it for something else? So this is a framework that we propose to better kind of study the subtlety of social dimensions in language. So as you can see, it's actually very intertwined relations between human behavior, language, social, and linguistics. One cannot solve those problems by just using methods in one subject. And there are a lot of challenges that we need to address in order to clearly understand the language used in social contexts. So on this page, I list 3 of them. No specific order, that ManLab has been working on to approach like NLP in social contexts. So first, a lot of the social scenarios that we are looking at are what we call like low resource scenarios. Well, although we have huge amount of data, there are very limited labeled data that we can use to build the classifiers or build other models. How we could kind of leverage advances in the machine learning or unsupervised representation domain to deal with this. The second is the complex and the subtle language behaviors that I shared with you all through the 2 theoretical framework. So there are a lot of subtlety there, and how can we kind of model those different aspects is a key challenge. Third, for any given corpus or context, where is the traditional domain or setup that we use to understand NLP problems, social intelligence or understanding of the social scenarios goes beyond a specific corpus. And it's also very hard to organize or reason over those social interactions, and even more difficult to mine some structured data or knowledge from those interactions. So in today's talk, I'm going to use three specific examples to quickly go through how we formulate problems and build methods to understand the people's language use in social contexts, with a strong emphasis on how to build models with limited annotated data and more structures. Also, I forgot to mention it. So after each section, I will have a natural stop point for questions. So feel free to either share the questions in chat or save it in the transition stage. Okay, let's go to the first one. Modeling good faith persuasion in language. So persuasive communication is everywhere. So persuasion shapes our attitude and behaviors and has been widely used in ads, in political campaign and loan request. So in this talk, we mainly look at how persuasion works in crowdfunding context. So here we choose Kiva, which is the largest peer-to-peer learning platform in US, to see how we can better understand the persuasion strategies people use when advocating for loan request. So here is one advocacy message from Kiva. So based on the system log, we know that it has persuaded 3 out of 50 people to lend. But why it leads people to give? Instead of building a classifier here to predict whether a request is going to succeed or not, here we want to figure out what are some explicit strategies or acts in the language that make it persuasive. So we are going to answer 3 questions here. What are some widely used persuasion strategies? How can we computationally model them? And how do those persuasive strategies affect request success? So speaking of persuasion, there has been a lot of work in computational argumentation, where people look at the relational support structures about the claims. However, persuasion differs from argumentation since it focuses more on the language parts that shape, reinforce, or change people's attitude. So in this work, we utilize existing persuasion theories to get our understanding of persuasion strategies in language. So as Kahneman said in his Nobel Prize-winning book, when people are evaluating requests or information, there are 2 systems going on. System 1 is fast and emotional, and people rely on superficial cues to make decisions, such as only a few left, that must be good, or expert recommended, so I should go with it, or people who I like are using it, maybe I should use it as well. System 2 is slower, more deliberative, and more logical. So people carefully evaluate the request and ask questions like, are those facts correct? Are those conclusions warranted? We took advantage of this line of due processing theory from psychology to understand the effect of persuasion. So the heuristic processing, the system 1, actually occurs when we don't think deeply about a message and we are persuaded by the superficial cues in a message or situation. In contrast, system 2, the systematic processing occurs when we think deeply about a message and we are persuaded by the strengths of the arguments. So for example, a person might lend to a loan because the borrower's appearance or because the advocator is from a high status member. This will belong to the heuristic processing. In contrast, a message could contain very concrete descriptions of why a loan is worthy or why this person is worthy with numbers and evidence. This may trigger the think slow process. In the following, we are going to translate those persuasion theories into something that we can measure in language. So the first aspect we introduce here called scarcity. So it means that people value an item more when it becomes rare or urgent, such as this loan is going to expire, please help. We have emotion. Messages full of emotional valence make people care. Like the picture of widow Bernice holding her baby in front of her meager home brings tears to my eyes. We have identity here, which says that the people like their identity more, so that they are more likely to be convinced if something comes from their own community. We also have commitment, that is, whenever we made a choice, we like to convince others that we made the correct choice so that others should follow. We have concreteness here, whether a request is providing concrete facts or evidence that can demonstrate the strength of their argument. We have impact. So by emphasizing the importance or bigger vision impact of the loan, like she can provide a better education for her daughter. So inspired by these persuasion theories and also social influence framework, as well as the data representation in our corpus, we end up with 6 persuasion tactics here in language. It's worth mentioning that there are more persuasion strategies such as authority or like reciprocity. We do not find enough data correspondence in our corpus. So in a straightforward manner, now build on those categories, we can annotate some amount of sentences in those advocacy messages and then train classifier to predict the persuasion strategy in each sentence. However, it's time consuming and expensive. Instead, we want to figure out whether we could predict the persuasion tactics with limited amount of annotated data, that is in a semi-supervised manner. So from a model perspective, we are interested in how to design models for semi-supervised learning with document supervision. So explicitly, our document level supervision is how many people get convinced by a request. And then the sentence level labels are the persuasion strategy, partially labeled. So again, to give it a more intuitive picture, this is a traditional semi-supervised setting that is widely used today. Take our context, for example. A typical setting is that we have limited amount of labeled sentences with their corresponding persuasion strategies, and we have extra large amount of unlabeled sentences. In our setting, remember that we have labels at the document level. So to this end, we propose this semi-supervised setting with global or document level supervision. The intuition is that we want to use the document level labels to supervise the learning of sentence level labels. So similar idea have been used like in computer vision, where people use like image global labels to uncover pixel level labels and the bounding box of objects. So this is the first model we introduced back to 2018-19. So it was a simple and effective semi-supervised model where we first use sentence encoder to process each word. We also introduce attention to learn the characteristic words associated with persuasion strategy. So similarly, we process each sentences and also impose the attention to learn the importance of each sentence. And together we predict how persuasive this message is. So one assumption we made here is that each sentence only use one type of persuasion strategy. So it's a semi-supervised objective where we have the persuasion strategy prediction at a sentence level and also the regression of persuasiveness at the document level. Okay, so this year we kind of improve this model, building on all the recent advances that we have. So we further propose this weekly supervised hierarchical model. So the overall setup is similar. At a sentence level, we kind of assume that we first the input sentences are encoded into two kind of aspects. So we assume that it has the strategies, which is a variable y here. We also think that it may contain the context or content information. So we try to use a variational autoencoder to decompose them into this strategy and also the content here. And then we can further use a decoder to reconstruct the input sentence. We use both parts to predict the document level. So again, this is similar architecture. We used the 42,000 advocacy messages from Kiva, and we annotated the 3,000 sentences with their corresponding persuasion strategies on Amazon Turk. So here is some of the results if we only look at the simple hierarchical net. So as you can see, compared to LSTM, it has slightly improvement. So here the setup is that what if we only use 20 data points, 30 data points, 50 data points, or we use all the amount of data that we have. So as we can see, the difference is a little bit larger when the number of data points is small. When we switch to BERT and or use this kind of recent architecture that we introduced, we saw that there is much better performance compared to baselines, both in terms of the sentence and document level task. Not only with Kiva, so we also use the two subreddits from Reddit. So one is like asking for free pizza based on a message. Another is to asking for loan based on a message and some evidence that the people provide. It's called r/borrow. So as we can see, there are consistent improvement in terms of the persuasion strategy prediction. So now with all these kind of models that we have, we further apply it to all messages in our corpus and visualize how persuasion strategies correlated with success. So we build a simple linear regression model here so that we can also control a lot of confounding variables in this case. We found that on Kiva, when people mentioning shared identity, expressing concrete details in the message, help their request fulfilled, and mentioning the limited amount of time, like scarcity or urgency, does not work well for this context. We further applied our persuasion strategies to another context. I introduced this earlier, so it's called a random acts of pizza, which is to request and give away pizza to strangers on Reddit, as you can see from this example. We found that in this context, concreteness, emotional, and scarcity are the top three most important strategies to convince people to give you free pizza. And together, those two experiments showed that those persuasion strategies are differently effective for different contexts. It is not that one is always right or good. It is more about using it for a proper context. Okay, so that's the first section of the talk. I'm going to stop here and then check whether we have questions.
I have a question. It's a clarification. So per document, you have a single persuasion strategy, or do you have, can you have multiple?
Sorry, I cannot hear you very clearly, Swaba. So are you asking for the sentence level label? Do we have one or do we have multiple?
Yeah, document level as well as sentence level. Yeah.
So for the sentence level, we assume that each sentence only have one persuasion strategy. So in the actual labeling stage, in the pilot, we actually make it multiple choices, but we found that majority, like around 90-ish percentage, people only choose one strategy for it. So later we frame it as choose the strategy that is mainly reflected by the sentence. So each sentence only have one persuasion strategy. On the document level label, so in the Kiva context, because we know like after this message is sent, who read it and who like learned to it. So that's like we kind of define the overall persuasiveness there. And similarly, on the r/borrow or on r/r random acts of PISA, so we have the label provided by the bot on whether the transaction happened successfully or not. So in that case, you have this kind of document level label. But again, the sentence level label as a specific strategy, and then document level are more like the outcome, whether it succeed or not. Okay. Yeah, I didn't see any questions in the chat, so maybe we can move ahead. Okay. So again, persuasion not only comes from language, it could also come from the surrounding context. So as you can see, in addition to the language, potential lenders also know who is the advocate here, here, and also who is a borrower. So if we click that link, we saw that there are more information that may influence lenders' decision of to give or not. So we can see the borrower picture, we can see the loan description, we know the blurb, we know the borrower location, the loan amount. So in a relatively social computing setup, we extract a lot of features from the context. And then, for example, we look at the profile pictures, we obtained a large set of findings. So here I had some of them. So we found that people in general, like 3% less likely to make loans to female borrowers, and they are 3.5% more likely to lend to borrowers who have a positive or big smile on their faces. And also, when people first join the platform, they lend very frequently. But as they stay longer and get more experience, they tend to be more strategic and lend less overall. Also, in a recent work, my amazing undergrad further look at the ordering of the rhetorical strategies on persuasion. So, for example, should I begin with a concrete message first, or should I begin with politeness, or should I begin with empathy? What is the order of emotion and concreteness? So highly encourage you to check out our papers. So some of the findings we have here is that if you consistently rely on facts or concreteness, it may backfires and hurting persuasion. So far, we look at the persuasion strategies in language with limited supervision. Again, there are a lot of similar socially low resource settings like politeness, social support, humor, or other form of subtle social interaction. As mentioned earlier, most of them have limited labeled data. So how can we kind of propose a relatively generic framework for classification with limited data? So in a recent work, so we also introduced a new data augmentation method called the text mix-up, inspired by the recent success of mix-up image classification task. So the main idea here is that we could perform linear interpolation in textual hidden space between different training sentences to create like infinite amount of new augmented data. So here is the overall overview of the text mix-up. So it works by, for a given sentence X, we first randomly sample another sentence X prime, and we encode them separately in lower layers in a multi-layer encoder till a specific layer M. And then we can perform this linear interpolation of them after layer M. And then here we use the coefficient lambda to kind of control the trade-off here. And we then can continue doing the forward parsing in the upper layers doing this mixed representation. We assume that the labels of the mixed sentences should be the interpolation of the original sentences as well. And then this also enables us in the training to kind of minimize the KL divergence between the mixed labels and the probability from the classifier as the supervision loss. So one key aspect here is that how would you pick which layer to mix? So we made this decision based on the recent interpretability work that different layers of BERT, let's say, demonstrate different linguistic properties. So we basically divide them into surface and syntactic and semantic, and then try to choose the layer that contain both syntactic and semantic information as our mixing layers. We further propose like a generic framework for text classification called a mixed text. So the core idea is to leverage text mix-up on both labeled and unlabeled data. Again, we found that it demonstrates better performance when compared to different baselines. And again, the improvement is much bigger when the number of data points is relatively small. Okay, so now I'm going to move into the second part about how we understand those complex and subtle language behaviors by looking at neutralizing subjective biased language. So the first part is more about like how to help borrowers or loan allocators to write a more persuasive message. But what if there are some unwanted framing in the language? How should we get rid of it? So to give you a quick background, I mean, we have seen many great work recently on biased language. So a recent web survey from Gallup also showed that overall the US adults estimate that over 62% of the news they read in newspapers, seen on television, or hear on audio radio is biased. And people are even more critical of the news they see on social media. From a language perspective, so what makes certain texts biased and others neutral? If we read those two headlines here, so one is that John McCain exposed as an agent of the Rothschilds versus McCain accused of accepting inappropriate donation from Rothschild. So which one is relatively neutral or more biased? The job for us is that how could we, if we figure out which is neutral, which is less biased, how could we automatically suggest less biased alternatives to the same text? So let's be a little bit concrete here. So what is bias? We have been using this word in many different domains. So in our context, we mainly focus on subjectivity bias. And in more detail, it means that inappropriate subjectivity. So subjective biased text may involve subjective attitude, use presuppositions, or casting doubt. So in the example we just saw before, it is biased in two ways. So first is the usage of word exposed here. And then the second is a description of agent of Rothschilds. So in this specific work, our job is to deal with the subjectivity bias that presuppose John is an agent. We haven't dealt with the non-subjectivity bias in this work and leave it for future exploration. So based on previous work, we also found that there are three types of biases in the corpus. So framing bias here refers to using subjective words or phrase linked with a particular point of view, such as pilfered from. And epistemological bias here means that linguistic features that subtly, often through presupposition, to modify the believability of a proposition. And the demographic bias here means that there are some presupposition about the particular gender, race, or other demographic categories, such as a leader programmer usually spends his career, which kind of presuppose that all programmers are male. So this is the main goal of this work. That is, how could we remove such subjectivity bias from a sentence and to further neutralize that sentences? So instead of pilfered from, maybe we could consider based on. Instead of will bring back, we can consider which is promoter's belief or hope will bring back. his career versus their career. So we utilize Wikipedia to construct corpus here, since writers and editors they need to avoid using biased language. So this policy is called a neutral point of view on Wikipedia, which requires that all the encyclopedia content must be written from a neutral point of view. We look at the revision. So if a version is biased, editor may change it to another version and specify whether this revision is for neutral point of view purpose by using their edit comment provided by them. So this is our label. So based on those kind of revisions, we introduced this parallel corpus of biased language with over 180,000 sentence pairs. So we can see like the left is the text with subjective bias, and then the right is the same text from a relatively neutral point of view. Based on this corpus, we also introduced the two baseline to neutralize text. So the first system we introduced here is concurrent, which use a simple encoder-decoder framework. So we give each of the bias statement and then output the neutralized version. We use BERT as encoder here to process the input text, and then the decoder is tensional LSTM with copy mechanism. We also pre-train the decoder as a language model using the neutral text. Doing this will enable us to have a very nice data-driven prior of about how targeted sentences should read like. We also add a token-weighted loss here to better model the neutralization process. So the intuition here is that the source and the target should have a high degree of lexicon similarity, but then the goal is to learn the structure difference, not simply just like copying words into the output. We also introduced a second system to simulate how humans read a bias statement. So in addition to an encoder here, we also introduce a tagger. So this tagger will predict whether each specific token is potentially biased or not. And then we can use that prediction together with the encoder representation into a joint presentation and use that as the input for the decoder. We decode the sentence as normal. We also use the same pre-training and the weighted loss we just introduced. So why should we have two systems? There are both pros and cons of different setup of each specific architecture we used. So the concurrent one is straightforward, easy to use, but then the modular one is more controllable and interpretable. We further tested the model performance using our data set. And in addition to evaluate the BLEU and the accuracy, we also introduced the fluency, meaning, and the bias human annotation. As you can see from those two lines, the first impression is that there is no clear winner. So the modular network seems to be good at reducing bias, and also the concurrent system seems to be better preserve the meaning and the fluency of the original text. So there is no clear winner in terms of the experiment that we did, but they all achieve better performance in terms of reducing bias compared to the baselines. We further apply the model trained on this corpus on some of the out-of-domain data set. So as you can see, this is on the political books. So the original sentence is activists have filed a lawsuit. So our two systems change it to critics of it have filed a lawsuit, or critics have filed a lawsuit here. When applying it on news headlines, we saw that Zuckerberg claims Facebook account is the original text. We change it to Zuckerberg stated Facebook account, or Zuckerberg says Facebook account. When testing it on campaign speeches, the original sentence is this includes amazing Americans like. We change it to this includes American can like, or this includes some Americans like. So as you can see, the models is doing some interesting modifications here. Okay, so any questions until this point? Okay. Okay, I think there seems no questions, which means that maybe I'm explaining everything very clearly and persuasively. So that's also a good sign. In the next like 5-10 minutes, I'm going to quickly go through the last work that we are doing, and also we can open for more questions and the deeper questions. So the last set of work that we are doing is to look at those social interactions, like informal conversations. Here, I pick the summarizing dialogue through conversation structures. So conversations is increasing dramatically these days. We use Slack forum, and it's challenging and time-consuming to resume all the content before starting any conversations, especially when the chatting history becomes very long. So how to process and organize those informal interactions into some concise and structured data becomes technically and socially important. So one possible solution is that, okay, let's just try to generate dialogue summaries. So the task is that for any given dialogues, we want to generate several sentences to convert the main idea in the conversation into a 2-sentence description. So on the left, we saw this is a phone call transcripts, and then on the right, we saw this is the 2-sentence summary. So most of the work so far have been focused on like a single speaker documents, like news report, scientific publications, or encyclopedia articles, or similar domain. In those contexts, like the text is relatively structured, and it's usually like elaborate a core idea in a third-person point of view. And the information flow is relatively clear through paragraph or sections or titles. So unlike those documents, conversations are usually less structured, and they are informal. There are reconfirmations, hesitations, interruptions. So the important information might be scattered in the whole chat, making summarization models harder to focus on the informative utterance. So there has been certain patterns that our community use to understand the conversations and help conversation summarization. So for example, you can view it, treated the conversation as a whole, which we call the global view. Or we could introduce the discrete view that treat each utterance as an individual unit. We propose that more structures from conversations could help represent the conversations better, and then as a result, help the conversation summarization task. So the first structured view we introduce is the topic view. That is, one single conversation may cover multiple topics. So if we think about a phone call conversation, greetings, invitation, sharing party details, outcome of whether the person is going to the party or not. Another view we introduce is the stage view. That is, conversation develop certain patterns as the conversation progress. So it could begin with introduction, talking about problems, talking about solutions, wrap up. Next, the goal is that, okay, so now you have these conversations, how could we extract those structured views in an unstructured way, since we don't have any annotated labels for those views? So first, for each conversation, we use the pre-trained sentence representation to get the representation of each utterance. And then for the topic view, we use the topic segmentation algorithm. So here, like a C99, to calculate the similarity between any adjacent utterance in a window to split the conversations into different segments. We further use a hidden Markov model here, where the hidden states are the stages and the observations are the representations. So try to see like what is the specific stage of the conversation. One thing to worth noting is that we use a fixed ordering on the stages and only allow the transition from the current stage to the next one. So like for the previous example we saw, if we use topic view, we may end up with text segments like greetings, today's plan, plan for tomorrow, plan for Saturday, pickup time. From a stage view perspective, we have openings, intentions, discussion, conclusion. Based on all the kind of view that we extract, we further propose this like a multi-view seek to summarize conversations. And it includes two key components here. The first is our conversation encoder, and then the second is the multi-view decoder. So in the conversation encoder, each view, like a different blocks, is encoded separately, and we use a special token at the beginning of each block to get or represent that block representation. We further use the LSTM to aggregate each block's representation to get the view representation. In terms of the decoder, overall, we follow the general transformer decoder to generate summaries. Differently, we introduce a multi-view attention layer in each transformer block. So the multi-view attention layer first decides the importance of each view. So, and then the multi-headed attention is performed over our conversation tokens from different views and then form the corresponding view representation. The final results are further combined based on the view attention weights, like the alpha key here, and then continue doing the forward parsing. We performed the experiment on a recent human annotated data set called Samsung. So it's actually a daily chit-chat corpus with a lot of conversations, and most cases the participant numbers two, but there are also multiple participants. Here are the baseline results. So we evaluate the performance using the ROG score here, which compares the machine-generated summary and to the reference summary from human. And it counts the co-occurrence of the unigram, that's a ROG 1, and background, that's a ROG 2, and also the longest common sequence here. As we can see, when we add the structured views, it helps a little bit in terms of ROG 2 and ROG L. Our multi-view BART here, using like both stages, achieved better performance compared to the baseline or using either view, a single view here. Those results are also consistent with human annotation performance. So where we ask people to rate the quality of summary from -2 to 2. And as you can see, the multi-view demonstrates a higher quality from qualitative annotations. We further look at like why this task is challenging compared to like a regular text summarization. So, and summarize 7 challenges here for this specific corpus. So we found that there are a lot of informal language use, so such as like internet slang, jargons. There may be multiple participants. There are like extremely long, like a turn of conversations. There are also like a referral or co-reference, like talking about a third person in their discussions. There are repetition, interruptions, like 2 people speaking at the same time. There are also like a negation, rhetorical structures that the people use a lot, and also the social role change or language change here. So in the beginning, you may begin with a person who asks questions, and then later switch to a person who challenge or who like answer questions. So especially when we visualize such challenges in terms of the data points that we have, we saw that the generic is the overall performance that we have. So we can see it's pretty high. But when we kind of break down the performance into each specific cases, we saw that there are several categories seems to contribute the most errors for the prediction. So referral and co-reference, repetition and interruption, and also the multiple turns seems to be the key challenges here. So this calls for more intelligent summarization methods to be developed to track those challenges. Okay, so to give a quick summary here, so we found that conversation structures help summarization, and combining multiple views improve performance. Despite that, dialogue summarization still faces many challenges. To kind of sum up, so in this talk, I mainly talk about the 3 lines of research as examples to show how we kind of understand the language in social context by looking at the persuasion, subjectivity, biased language, and also like summarization when it comes to informal chats. So that's all about my work. Thank you very much for listening. I'm happy to take any questions here.
Awesome job. Thank you. Okay, so we have time for a couple questions. Okay, maybe I can get started. Yeah, so in the first part, and sorry if I missed it, but you are able to identify characteristics of a post that makes it more likely to be funded, like identity, scarcity, and so on. Have you tried a conditional generation that would rewrite these posts and make them, more likely to be funded, and doing some A/B testing there?
Yes, that's a great question, and it's more than technology questions. So we actually had efforts in that space. So first, think about a lot of the consequence. So I think it's possible from a technical perspective, we can definitely do conditional text generation. So for example, like if you present certain facts, we can help make it more persuasive, make it more emotional, make it more like a concrete, or emphasizing the vision using all the different persuasion tactics we introduce. So technically it's doable, and we have data. But then like it suffers from a lot of the ethical aspects that we can think of, and we didn't move forward with that. So some of the issues we encounter is that so there is a key challenge that you will make it a very persuasive, so specific audience. So basically it may be used by malicious intention people to use it to attack or manipulate. So that's the first part. The second part is like what you mentioned as A/B testing. So it's really hard to kind of apply it to practice. So when we use the Reddit, random X pizza, or the borrow, like there's no way you can like disrupt or destroy the community by posting a lot of fake content there. So it's going to be problematic. And also if we think about the Kiva context we use, it's also like people come there to for their like entrepreneur or for their like a business. It's also really hard just to experiment from an ethical perspective. So we decided not to move forward with that. So at least for now, although at the same time we are like kind of thinking about how to move forward with caution and how to make it more valid. Well, yes. I guess like my key takeaway is that we should not stay away from persuasion just because that term seems dirty and seems like linked with brainwash or others. But we did encounter a lot of pushback from IRB and from other aspects.
All right. Yeah, thanks a lot. A lot of ethical questions there. More questions? Sorry, I had to take over because, oh yeah, go for it.
Oh, yeah, hi, Dee. Yeah, so it's very interesting. I really like the idea with the multi-view summarization. There is a few parts I think I might miss some details. So first, like, is the multi-views are already predefined? So you have like a distribution on all like a fixed multi-views. And second question is, like, do you think this is kind of like ensemble of like a kind of like ensemble method? Like, have you ever played with, like, if I want to, like rather than following the distribution from your classification model, like what if you inject, like, I just want the summarization to be like towards this view? Like, do you see just like by modifying the transformers, it does like things as we wanted?
Yeah. Both questions are great. I think I went very fast in this portion. So in terms of the multi-view, they are predefined. Well, predefined means that we need to first pre-process all the conversations. So like the two view on the screen right now, like a topic or conversation stage. So topic is performed as a supervised way of processing all the conversation we have. So every conversation will be like predicted with different text segments, and each conversation have a different set of text segments based on their specific topics involved, right? So this is already pre-processed. And similarly for the conversational stage, so we basically fit like each hidden Markov model over all the training corpus. So, and then like here the number of stages are fixed overall. So basically we have like 4 or 5 like stages. So we then kind of apply the model to estimate the stage of given like conversation. So anyway, those two are all like pre-processed already. And then later the model read a specific like block or segment. And I agree with you. I think from one aspect is more like an ensemble representation of the conversation, because that's the challenge right now. Conversations are very long and they are very like unstructured. So how to kind of arrange or kind of pick the right level of granularity to represent it is the key challenge. And I think why the method work here is that we actually provide multiple different lenses to view the same conversation. So yeah, so that's a really good insight. And you have a third question, I forgot.
Yeah. Another question is I'm just wondering, like, what if you before, like, you're giving kind of ensemble of views, and what if you just want the model to generate like a summaries with respect to a specific view? Like is your method having this control on this?
Yeah, that's a fantastic question, and it's also ongoing work. I can share more, but you should also like read our papers in the next 12 months if it can be published. Yeah, so we are also doing like a controllable generation for conversations, because when the conversations gets very long, you want to view it from different view or from different aspect. So for example, like if it's a conversation, if it's a big group meeting, I do not want to have an overall view. I just want to hear what my boss talk about or what a specific person shared in that conversation, and then all the discussions around that. So in that case, we need to focus on a specific participant, or it may be topic wise. So for example, like even in this talk, in the very beginning, we did a lot of chit chat, right? So maybe a person is like, I don't want to listen to the main talk content. I only care about the chit chat. Just give me the chit chat summarization. Or I care about the main content. Give me the main content and do not tell me about chit chat. So in that case, the topic wise kind of summarization will be possible. So I think that's a excellent question. So we have ongoing work to make it more controllable, so that the users can play around with the summarization model.
Great, thank you. I'm looking forward to that. Thanks.